Today, we will discuss the background summary, underlying economics, and implication for agriculture in the article Ag Biotech. It's not just what's for dinner anymore, but the future content of our medicine cabinets. It's written by Jennifer Medlock and Edna Insidel. Hi, my name's Hannah Miller.
My name is Lee Melly.
Just a little background information. The use of genetically engineered crops has been an innovation in the agriculture industry for multiple decades. This technology has not only improved the welfare for farmers, but also food processors and even the general public. Engineered foods have provided Earth with sustainable and nutritious crops that have the ability to deliver multiple benefits to the consumer. Genetically engineered crops have the abilities such as resistance to specific herbicides and also increased amounts of nutrients. Farmers have been generally a main consumer for the engineered products, but a new use for these engineered traits have been introduced. Produced through plant molecular farming, a new variety of food is grown genetically not for food, but for pharmaceutical purposes such as medicines, vaccination antibodies, hormones, and growth regulators. The goal of this is to produce commercially useful proteins for pharmaceuticals and industries, which lower the production costs.
There is a significant difference between genetically engineered organisms and plant molecular farming. Genetically engineered crops are organisms which genetics have been altered to improve the efficiency of that particular food. Plant molecular farming are engineered organisms whose genetics have been altered to create pharmaceutical products. The key difference between these two technologies is plant molecular farming isn't used strictly to benefit the food chain like genetically engineered crops are.
The PMF crops are highly regulated from the Canadian Food Inspection Agency at all times and are labeled if any genetic changes or traits added to them. However, since there is a risk to human health, regulations must increase to protect the health of consumers. The public's view on the technology was conducted by surveying populations in different areas to bring up questions or concerns that the public had. The public generally had four main concerns: food contamination risk, safety issues, appropriate regulation, and long-term impacts. Contamination was a major concern for the Canadian public, causing a disturbance in the food chain and possible bioterrorism.
Acceptance of this technology is dependent on the media's decision. There are currently 5 applications that are approved from the media for commercial production. Trypsin in corn, which is a protein taken from corn used in biopharmaceuticals, interleukin in tobacco, which has potential for treatment of Crohn's disease, Norwalk virus vaccine in potatoes, gastric lipase in corn used to treat cystic fibrosis, bioplastics in corn, which use biodegradable molecules to produce bioplastics. Regulations of plant molecular farming were all based on the media's reaction towards the application. The technology was favored when it was aimed to provide benefits to improve human health. If the technology is used to provide more benefits to the economy rather than the interest of society, then it was disfavored. In summary, the acceptance of this new method was based on toxicity, stability, location, production platform, and the amount of acres grown.
The underlying economics of plant molecular breeding.
The overall objective of plant molecular farming is to create commercial pharmaceuticals while lowering production costs. However, there is a diverse consumer demographic since it is favored and feared by many. This method of technology has a variety of economic benefits such as increased supply of pharmaceuticals and reduced production costs. Production costs can be lowered because plant molecular farming creates materials used for pharmaceuticals. When these materials are increased, the quantity of medical materials are produced at a more efficient rate, while at low production and labor costs. The technology also improves human welfare, allowing pharmaceuticals to be induced orally rather than by a syringe, providing more comfort to the patient.
There are many implications involving these plant molecular farming methods and the supply chain of crop commodities. The industry of plant molecular farming starts at the root of all supply chains, the technology and the breeders. There are many companies that focus on creating new varieties and products for the health sector. A few of these companies are VideoGr21 Technology from North Carolina and Anthea from California. Together, these companies work together to create better products for their consumers. Plant molecular farming is here for a reason. Biologists help farmers as they create new varieties for them to grow. These new varieties are transgenic crops for medicines and industrial products. The biologists expand useful genetic diversities for crop improvements. For example, the use of certain germplasms has been very successful for improving many crop species, but have few difficulties with undesirable alleles associated with the lack of adaptations. Here, this picture shows how desirable genes or traits are chosen to keep breeding with, and the red flag shows undesirable traits that biologists want to stay away from. These plant biologists have a few regulations they need to undergo to keep making new varieties. The Canadian government regulates all cases and experiments that the biologists are working on. They all must follow the Canadian Food Inspection Agency policies as mentioned earlier.
To summarize, the use of plant molecular farming is a very interesting and innovative technology. It has proved to have outstanding benefits toward human health and the economy as a whole. With lower production costs, this can contribute to the medical manufacturing process. This technology has a strong potential to become a more commonly used variety for the medical industry due to its benefit to its consumer. However, there are many risks humans should be aware of, such as the risk of contamination of certain food groups, or risk of disease being brought into the food chain. Plant molecular farming is a very complex technology that has its advantages and disadvantages towards its objective, but should be overall considered as an alternative and a step forward in the future of pharmaceuticals.
I did my best, but I guess my best wasn't good enough. 'Cause here we are back where we were before. Seems nothing ever changes. We're back to being strangers, wondering if we are